Okay, now that you've had a chance to play around with Inkscape and use that graphics program, I want to kind of define more specifically the mathematical terms that we're using. First up, congruence. Congruence means same size and same shape. So if I have two shapes that are identical and the same size and same shape, they can be put on top of each other and covered completely. The ways that we can manipulate these shapes to move them around and change the way that they look, one of the ways is called isometries. Isometries are these transformations that maintain congruence. And you've heard of transformers, right? Transformers, they change their shape. So transformations are a way to change the shape, but it still maintains the same congruence, that it's still the same size and same shape. So here's some examples of some isometries. The first one up is called translation. Translation is just to move or slide a shape by a vector. And a vector is just moving it in a it has a direction and a magnitude. A magnitude just means length. So it could be, at some angle with a length, or it could be, a composition of going one direction and then another direction, like going north so far and then west so far, or something like that. So moving by a vector, now we're going to do a couple of those. So let's do first the translation by a vector. So I want to copy this vector over to here and move that each point. I'm going to move each point over by the same amount. Okay, so I want to draw a line from the end point of this vector to one of these points. Alright, and then I'm going to trace this with the tracing paper, this patty paper. I'm going to move the vector over, or move the shape over this far. Okay, and then I just want to copy this line to use as a reference, so that when I slide it over here, I can still keep it going in the same direction. Alright, so I'm going to move this shape over to here. So I'm just going to press real hard with my pen, and then I can pick up my paper and copy that over. If I can make a mark strong enough. You might not be able to see it on the video, but I can see it right there. Okay, so that is the vector that I want to translate this shape by. So now I'm just going to copy this whole shape, and when I copy over it, it is the same size and same shape, right? Not quite perfect. Okay, so now I'm going to take this point right here and I'm going to move it over to this spot right here, but see, if I do it, I might mess up and change the angle, right? So I need to translate this vector over to here again, or maybe I can just make sure that my angle is correct just by let's see, copying this vector over. So let me draw this vector on here and make sure that my angle is the same. Okay, and let's draw it a little bit past, just so I can use it as a reference. Alright, and let's draw this again. Now I'm going to keep this angle the same. So if I keep the angle the same, now it will stay in the same spot. Okay, so now I can press hard with my pen to make a mark through the paper, and I can see it here, but you may not. Okay, now I can finish my translation. Okay, so I have two congruent triangles. We'll call this A, B, C, and this would be A prime, B prime, C prime. And these two shapes are congruent because they were not changed in any size or shape way. And this was an isometry. Okay. Okay, up next we have reflection. A reflection is to mirror across or flip over a line. So if I were to mirror this shape that I made before, I could flip it over a line, or mirror, right? If I fold the paper and put this shape here, you could see that this shape is now mirrored. Okay, so let me grab another piece of paper. Okay, so I want to mirror this shape across, I'll say this line. You could mirror it across this line or any random line that you want to draw. Okay, so let me first make my congruent shape on the paper. And I'm going to draw my reference line on the paper as well. Okay, and now I want to mirror this over here, so I could just flip it across the line. And that would be the spot. Now, I do want to make sure that I keep the same facing, so let me just, I'll just draw a line. Needs to be actually perpendicular to this line. I could fold it, that's what I'm going to do. I'm going to fold it across. That line. And then on the back side I can draw that point. Draw those points in. And now I'll put it back on the paper. And now this is where my new triangle is going to be. So I'm just going to push those dots in to the paper so that they'll copy through. There we go. So now that shape is mirrored across that line. And one thing you want to notice about this is that all the lines are in equal distance. The points are reflected in equal distance away on both sides of the line. So this is equal to this, that's equal to that, and this length, the perpendicular length to the line, is equal to that length right there. Okay, so that is reflection. Last isometry is rotation, and that's to turn around a point. So you're given a point, you're going to turn around it by some angle. So by an angle. So that's kind of an important point, is to have an angle in there too. So let's say I do 180 degrees, I could do 90 degrees or 10 degrees, it doesn't really matter. So what I want to do, I'm going to put the point in there, draw my shape, and now the rotation that I'm going to do, I just keep that point there on that spot, and you can see how this is rotating. So my original angle will say, let's say it's this direction, and I want to copy that down, so let's push that this. Not quite good enough. There we go. So I copied that through just by pressing pretty hard. It's a little easier with pencil than it is with pen. Okay, so say I want to do 180 degrees. That would turn it so that it faces in the exact opposite direction. And I'll just use this as my straight edge. So it's going to go over to there. So what I do is I take this point right here and I spin it around, and now my new direction is right there. So I just make my 3 points. I have to do it a couple times. There we go. And there is my new shape that has now been rotated 180 degrees. Same size, same shape, it's just changing direction. Okay, so one key thing about congruent shapes is that two things are congruent if and only if a set of isometries can be used to map one onto the other. And it could be a combination of these. It could be a reflection and a rotation, or a translation, a reflection and a rotation. It could be all three. Okay.